Rada Dani from Kosovo, currently a master's student at Hassan Pristina University in Pristina, Organic Chemistry Department. I'm grateful for the opportunity given by organizers to present our work. It is worth mentioning that this presentation and our work wouldn't be possible without my supervisor, Associate Professor Mrs. Arleta Rifati Nija. This work is done in research laboratory in organic chemistry and biochemistry. The presentation consists of information about the chemistry of chalcones and class of pyrazoles, and then a brief summary of the methodology used. Then we have obtained synthesis of chalcones and obtained synthesis of pyrazole carbaldehydes. And last but not least, we have results of our spectroscopy, hydrogen NMR, TLC, thin layer chromatography, and melting points. So the purpose of the work is orientated towards synthesizing new derivatives of substituted chalcones that will mainly show antibacterial and anti-cancer properties. Also, the same previous properties mentioned of chalcones have been found for new derivatives of substituted pyrazole carbaldehydes. Synthesize new pyrazole carbaldehydes and to make measurements with IR spectroscopy and NMR spectroscopy in order to confirm their structure and also as well as to measure their melting points to confirm their purity. Chalcones are known as benzyl acetophenones and belong to the flavonoid family. In chalcones, we can see that two aromatic rings are linked by a 3-carbon aliphatic chain and are considered as alpha-beta unsaturated ketones. Can be synthesized in laboratory by aldol condensation between benzaldehyde and an acetophenone in the presence of the base, and mechanism is shown below. Pyrazoles are considered as 5-member ring systems containing 2 double bonds and 2 adjacent nitrogen atoms. Medicinal chemistry application of pyrazoles and fused ring system have been found in drug discovery. As here is shown the structure of pyrazole. The pyrazole carbaldehyde is shown below. Methodology and equipment. All laboratory tools that are used for synthesis. Used for our work is apparatus for melting point, Buchi apparatus for IR spectroscopy, and NMR spectroscopy. Methodology of chalcones consists of 3 steps. The first step is that 2 millimolar of acetophenone and 2 millimolar of benzaldehyde are placed in a beaker and dissolved with a small amount of methanol. And then they were placed in round bottom flask, which we put a small magnet, and with a separatory funnel, we add sodium hydroxide 40%, and in total 10 milliliters are added by drops. The second step consists that the solution was mixed by magnetic stirrers for 12 hours and number of rotations is kept constant, 300. We observe a precipitate which is formed at the beginning. After immediately we add sodium hydroxide and start to mix the solution. Different colors of the precipitate were obtained. And the last but not least, we have the third step, which after 12 hours the solution is placed in a beaker full of crumbled ice and is mixed well. Later, using vacuum filtration, we obtain a residue, and the residue, that total amount of residue is left to dry. And later on is measured with analytical scale. And later on also, if it is needed, the crystallization is done with diethyl ether. Is it worth to mention that the residue is kept in a dry and dark place? Chalcones was carried out according to the following scheme, and in total we have 8 compounds obtained, as we named as 1C, 2C, and so on. Methodology of Pyrazole derivatives consists of 3 steps. First, we put in a round bottom flask 1 millimole of corresponding chalcone, and then we add 0.4 milliliter of hydrazine hydrate. And then slowly we add 4 milliliter of formic acid. Then we put in the water bath for 9 hours and kept the temperature around 90 up to 97 degrees, and the solution is mixed with magnetic stirrers with number of rotations with kept constant at 300. So this consists of the second step. And the third step is that a solution formed is put in a beaker full of crumbled ice, and then we filter that solution with vacuum filtration, and residue is left to dry for 24 hours. And if it's needed, the recrystallization is done with ethanol. And later that, the residue is left in a dry and dark environment, and later on is measured with analytical scale. Reaction of synthesis of pyrazole carbaldehyde derivatives, which in total we have obtained 8 of them, and we named as 1D, 2D, 3D, and so on. Results and discussions. So here we have IR spectra for a 2C compound, and as you can see from its structure, it contains carbon-oxygen carbonyl group of ketone, and also it contains carbon-carbon double bond conjugated, which is characteristics for derivatives of chalcones. And also we have a carbon-fluorine bond, and we have a peak that corresponds to a methoxide group. Also yield of this compound is 74.24% with melting point 188 till 194 degrees Celsius. And the photo of a compound obtained is shown here. Here we have IR spectra for 2D compound, and as you can see for its own structure, we have carbon-fluorine bond, a value peak, and also a methoxide group peak. And also here we have a carbon-hydrogen of aldehyde group here, and with a yield of 70% and melting point 136 up to 143. So here we have an NMR spectra for 2D compound, and as you can see, in total for this structure we have 6 singlet protoniums of methoxide group, and then we have in total 2 protonium doublets of CH2 group. Here we have total 1 triplet protonium of group CH, and we have 1 singlet protonium of aldehyde group, and in total 7 multiplet protonium of aromatic hydrogen bond. So we have IR spectra for 3D compound. As we can see, we have carbon-chlorine bond and carbon-fluorine bond with a value of 800, and carbon-fluorine bond with a value of 1400. We also have a carbonyl group for aldehyde, and the yield of this compound is 70.58% with melting point 145 to 152 degrees Celsius. So here we have NMR spectra for 3D compound, and as we can see, the values are shown in ppm, and we have total 2 doublet protoniums of group CH2, and then we have 1 triplet hydrogen of CH group, and we have also value of 1 singlet protonium of aldehyde group, and last but not least, we have in total 8 multiplets protonium of aromatic groups with value 7.90 till 7.98. Here we have NMR spectra for 4D compound, and we can see that we have 2 doublet protoniums with a value of 3.69 and 3.94, and we have 1 protonium triplet which corresponded to CH group with a value of 5.68, and then we have 1 singlet protonium of aldehyde group with a value of 8.61, and we have in total 8 multiplet protonium which correspond to aromatic groups with a value of 7.60 and 8.08. We have our spectra for 6C compound. As we can see, we have nitro group, so we have values for asymmetric and symmetric bonds in our spectra, which are 1520 and 1210. The yield of this compound is 74.76% with melting point 190 and 195. We have IR spectra for 8D compound, which we can see that values are kind of the same as with the previous chalcones. So we have nitro group with symmetric and asymmetric value, and also we have carbon-bromine bond. Now we don't have a value for carbon conjugated bond, but we have a value for carbonyl group, which corresponded to aldehyde, this part, and also yield of this compound is 85.32% with melting point 168 till 176. So we have NMR spectra for 8D compound. As you can see, we have in total 2 doublet plutonium with a value of 3.6 and 3.9, and we have 1 triplet plutonium here with a value 5.5, and then we have also aldehyde group singlet plutonium with a value of 8.9, and we have in total 8 multiplet aromatic plutonium which corresponds to value 7.3 and 7.8 ppm. It was done using silica gel as absorbent, and as a solvent hexane and ethyl acetate is used with the ratio 70 and 30. As you can see, 3C has the highest retention factor, and 6C and 2D compounds has the lowest retention factor value. So here we can see that 2D compound has the lowest melting point and 4C compound has highest melting point. Of chalcones were synthesized from benzaldehyde and various aromatic acetalphenones, and 8 syntheses of pyrazole carbaldehydes were obtained from chalcones. All these compounds obtained were identified through spectral analysis, hydrogen NMR spectra, IR spectroscopy, and also by melting point. All 8 chalcones derivatives synthesized. Compounds of pyrazole carbaldehydes, and it is worth to mention that all obtained compounds were found to be pure and the yields were satisfactory. Thank you for your attention.